Thank you, Praveen, and thank you, Howard, for having me here today. So I am Andrew Hill, one of the co-founders around 20 years ago at Pronet Solutions. We're a customer of Data on Storage, and Howard invited me here today, I think, just to tell you a little bit about our story, one of our recent challenges, and really just the solution that we've had with Azure Stack HCI to address that. So first, let me just give you a little context, I guess, by telling you some about Pronet. We're an MSP cloud service provider with clients that are primarily in the oil and gas and financial service industries here in Houston and the greater Texas area. We have designed private cloud solutions and provided private cloud hosting for more than 15 years, back before it was called cloud or private cloud, even I think back in the days when it was just called servers and data centers. But most of our clients have the traditional standard requirements that you'd expect from an oil and gas or financial services industries company, with virtual machines that are running email or VDI or remote desktop and other database servers, file servers, web servers, all of those type of things. So we provided solutions for these just through all of the technologies that have been available over the last 15, 16 years. Ones that you're familiar with, probably VMware back in the early days, and then every version of Hyper-V since then. So all of these solutions have always been hypervisors running over either direct attached storage or some type of SAN, and that has had various types and costs, but for the most part, it's been reliable enough over the years, if not pretty expensive. So the challenge that came for us recently, probably 3 or 4 years ago, when we had an existing client that began developing a new web-based application that was a little bit different than some of the other web applications we've hosted before, with just regular web front ends and databases and some storage. This one had a particular set of needs where that came out of its design, where it provides a place for batch uploads of document images that are then processed through OCR and stored and provided for end users to access all around the world. And part of what was challenging with this is that the client had no real way to gauge their growth, their data footprint growth. So it started off with a few terabytes, but quickly went to a couple, 20 terabytes. And then we could tell it was going to be growing quickly, but without really any way to model that from the client. So this is really outside of our traditional model, where we would go until we filled up a SAN or some other storage, attached storage, and then have to buy more in the form of just another incremental SAN or incremental storage device. And so that was going to be harder for us to provide storage as a service to a client that's billed monthly based on their usage. So this is why we were pretty excited back when Storage Spaces Direct was first announced back with Server 2016. We saw it as a way to become more flexible in how we grew our data storage as our client data footprint would expand unpredictably. So we were very early adopters of this technology and built it out using white labeled server systems and spending hours in the Windows Server catalog looking for certified hardware components. And after spending probably more money than I would like to think about, and going through several cycles of Windows updates that would cause massive headaches with Storage Spaces Direct, and usually end up with us having to engage Microsoft support and work for months on in some cases just to work through those, we realized that the complexity to provide an end-to-end Storage Spaces Direct solution was really more than we were wanting to handle. So it was at this point in time, I think, that we saw that Azure Stack HCI was on the horizon. And rather than be an early adopter and continue the cycle of frustration that we'd had over years, we decided to make the call and search out a partner like DataOn who could put together a validated solution and make it work and keep it current for us. So we'd seen DataOn's name for years, I guess, through our interaction with Microsoft events. And so I reached out to Howard and probably about a little over a year ago, and we began the process to design a system that would be able to handle both our everyday workload and this unique customer's web application, all in one scalable cluster that we could grow without large incremental cost down the road. So after a few weeks of discussion, Howard and his team helped us come up with a hybrid flash design that can handle both the high IOPS disk performance, part of our workload needs, and the ability to scale up our total storage capacity for a relatively low incremental cost. So let me show you on this slide a little bit of what that solution looks like. We came up with the initial deployment was a 4-node data on 4 compute node cluster, which had 2 JBOD attached that had been split up into zones so that each compute cluster could have a dedicated JBOD zone attached to it. And the JBODs have 14 terabyte Western Digital disk in it for low-cost volume storage that we can expand out. And then each of the compute nodes have 2 layers of flash storage, both 14 terabyte and 3.2 terabyte drives, so they could be divided into 2 layers. One tier that is made of specifically designed high-capacity 14 terabyte QLC flash drives, which we use for high-performance capacity storage. And then one layer consisting of the 3.2 terabyte NVMe flash for our volume caching. And so, see if I can go to the next slide and show you in storage spaces what that looks like. We're able to then take that array of disks and configure 2 separate storage tiers. One that uses the high capacity flash drives for persistent storage, with the smaller high durability flash drive still used as a cache layer. And then a second tier that also uses flashes for a cache layer, but the high capacity and cheaper spinning disks for capacity storage. So then inside of storage spaces, we're able to assign different virtual disks to our storage tiers and meet the specific needs that we have for each VM or application that we're hosting. So the results have been really great. With the storage split up into 4 virtual disks and assigned to these different tiers, we've been able to get per volume IO of over between 1 to 2 million IOPS combined between all the volumes on for example, like a 4K random read test, and then on some of our sustained write throughput of over 25 gigabytes per second in different sequential write tests. So in summary, I would just say that we have finally gotten the performance we were looking for from Azure Stack HCI and found the reliability and the ease of management that we were looking for by using a partner like Daton, who got us past all of the compatibility issues that we had with our DIY white box solution. So with that, I would like to say thanks to Howard for that. Thanks to the Daton storage team for getting us there. And I would like to turn it back over to him.